Hi, this is Brandon Baines in the math department at Lipscomb University, here to talk with you today about the fundamental counting principle. In this app, you'll learn how to solve counting problems using the fundamental counting principle. The fundamental counting principle provides an efficient way to count the number of possible outcomes of a series of successive events. And one example of this could be if James owns 3 pairs of shoes, 5 pairs of pants, and 4 shirts. We might be interested in knowing how many outfits James can create using those clothing items. Well, the fundamental counting principle provides us with a way to calculate that efficiently without having to go through and list all of the possible outcomes. We have a quick way of counting all these outcomes. Other examples that we'll look at will include things like passwords, and also like the number of ways that we could answer a multiple choice test. The fundamental counting principle states that the number of ways in which a series of successive events can occur is found by multiplying the number of ways each of those events can occur. So in our previous example, we had 3 events as the fundamental counting principle would define those. We had the event of picking a pair of shoes. We had the event of picking a pair of pants, and the event of picking a shirt. And using the 3 shoes, 5 pairs of pants, and 4 shirts that James owns, we can use that fundamental counting principle and multiply 3 times 5 times 4 to determine that he could create 60 possible outfits. Consider an 8-digit password that consists of only numerals from 0 to 9. We might be interested in knowing how many possible passwords we can create from these numerals. Viewing this in the fundamental counting principle, we would see that each selection of a digit of our password would count as an event. And so we have 8 events since we're creating an 8-digit password. Each of these events in this scenario can occur in 10 different ways. You could pick a 0, a 1, and so on all the way to 9. So the fundamental counting principle would say that the total number of passwords we can create is 10 times 10 times 10 times 10 times 10 times 10 times 10. That should be 10 to the 8th. And that comes out to be 100 million different passwords. One interesting thing to think about when we look at these counting problems along with password scenarios is to think about data security. And so we'll leave you with the question here of why do we have a lot of passwords that have other requirements? Most passwords are not as straightforward as this example. Many passwords involve special characters, capital letters, numbers, so on. And so we might think, what does that do to the number of passwords that we can create? Let's take a look at a second example. We have a local meat and 3 that offers 2 daily meat offerings, 5 daily sides. We might be interested in knowing how many possible orders of a meat and 3 sides we can order from this establishment. Side note here: if you've been to Sonic in the last few years, Sonic has on their cups that they have millions of drink options, and so this is a similar kind of counting problem to the math that they're using to come up with all these millions of drinks that they can create. All right, in our scenario, we're going to consider two different types of orders. Part A, we're going to consider that all the sides must be different. And in part B, we're going to consider that you might be able to order the same side. For example, maybe a double order of mashed potatoes, maybe a triple order of mashed potatoes if you really like mashed potatoes. And so we'll see what that does to the number of ways that we can order. All right, so in part A, when all the sides must be different, viewing this in the fundamental counting principle, we would say that we have 4 events. We have the event of choosing a meat. We have the event of choosing a first side, second, and third. And so, again, the counting principle tells us to multiply the ways each of those can occur, multiply all those together. So there are 2 meats, 5 sides when you're choosing your first side. Once you've picked your first side, there's only 4 sides left to choose from, so we're multiplying by 4. And then once you've picked 2 sides, there's only 3 sides left, so multiplying by 3 at the end. That results in 120 possible orders of a meat and 3 sides. When we go to part B, we see that we're allowing the double and triple orders, and we still have 4 events. But in this case, the product is 2 times 5 times 5 times 5, because each of those sides are allowed to be repicked. That results in 250 possible orders of a meat and 3 sides.